Graphics objects in JavaFX have properties associated with them. For example, the circle is a graphics object, and we saw some of the properties that it has associated with it, namely its XY coordinates of its center. It turns out that a binding property itself is an object, and we have in JavaFX binding properties defined for all primitive types and for strings, and these are called double property, integer property, float property, and string property. These are abstract classes which must have implementations in concrete classes. We would create instances of these properties using their concrete subclasses that would be simple double property, simple integer property, and so on. All the classes in JavaFX have binding properties associated with them. For example, a circle has a getter and setter method that will return and set the properties values. On the left-hand side of this slide, we see a generic description of binding properties and getters and setters and property getters. And on the right-hand side, we see it applied to a concrete example that we've already played with a bit, namely the circle. So let's start by looking at diagram A on the left-hand side. So if we have some particular class in JavaFX, there may be some property associated with it, a property type that we might call X, and there may be a property value type that called getX, which is a method that allows us to change or set that particular, or get rather, that particular property value. We can also have a set method for it, which you see in the fourth piece of code down there, public void set x property value type value. And then finally, we have a method that will get the actual object of the property, because the properties are objects. They have values, that's different, but they are objects themselves. And this last or fourth piece of code returns the actual object, the property object, to the caller. So let's take a look at how this applies in the context of the circle that you've seen already. So right at the top we have a double property for center X. That is the data member. Then we have two methods to get it and to set it. So the one is returns a double, and this is get center X. The other is void because it sets the value, and it's a method called set center X. So a getter and a setter for the value of the property for X. And then we have something that returns a double property for the center X property. In this next slide, we're going to talk about how to take two properties from different objects and bind them together so that when one changes, the other changes. Our first stab at doing this is going to be in one direction only. So this is called unidirectional binding, and we'll see how it works and how the binding does work in only one direction. We're not going to demonstrate this in the IDE. It's a relatively simple piece of code, so we'll just talk it through. So let's start by taking a look at the code that's in red. That's where the interesting things are happening. First of all, notice that we are instantiating two objects called D1 and D2. The declared type of both of those things is double property, but the actual type is simple double property. And that kind of makes sense because remember, double property is an abstract class. Although we can declare things to be of that class, we can't use that in the context of new. But because simple double property is a direct descendant of double property, then of course it would be okay to declare D1 to have that as its actual type, and likewise with D2. Notice that when we call the constructors for simple double property, we're passing an argument of 1 for in the case of D1 and an argument of 2 in the case of D2. So D1 is an integer, it's a double, and it has a value of 1.0, and D2 is a double and has a value of 2.0. But they're not doubles, they are simple double properties, which are different. And because of that, we're allowed to use the bind method with them. Notice the next line, immediately after the code that's shown in red, we do a D1.bind D2. Immediately after doing that bind, we've now bound together D1 and D2, so whatever value D2 has will immediately be the same as D1. Immediately after doing the bind, we do a system out, and you can see what happens if you go down to the blue box at the bottom of the slide. The first piece of output says D1 is 2.0 and D2 is 2.0. So we never did get to see D1 being equal to 1 because before we printed it, we had already bounded it to D2. And now D1's value is going to follow D2 around, and any changes we make to D2 will automatically be also made to D1. So in the line of code that you see between the two system out print lines, you see that we do a d2.setValue 70.2. Now what do you suppose that does? Well, it changes the value of d2 to 70.2, but because we've bound it to d1 using the bind command immediately under the code that's in red, that means that when we make that change to d2, we also make it to d1. And now when we do the system out print line, you can see that both D1 and D2 are reflecting the updated value 70.2. If we were to make a change, and unfortunately the slide does not show this, but if we were to attempt to make a change to D1, it would not be effective because D1 has been bound to D2. So if we were to set D1 to 3, for example, and then examine its value at this point, we would see that it's still going to be 70.2. Now what that illustrates and emphasizes is that the binding is in one direction only. Changes to D2 will affect D1, but the opposite is not true. In order for it to work both ways, we would have to have bidirectional binding, which is not the subject of this slide, but will follow in the next slide. So as promised, the next thing we look at is bidirectional binding. In this case, changes to either one of the two things that have been bound together will affect each of them in the same way, and that's why it's called bidirectional binding this time. Here is an example of how it works. First of all, take a look at the code that's in red. This time, when we do the bind, instead of simply saying d1.bind d2, we instead say d1.bind bidirectional d2. And that makes all the difference in the world now, because now if we change D1 or if we change D2, then both D1 and D2 change to match the latest update that was made. The code illustrates that down below then. We start by setting D1 and D2 both, or each of them to 1 and 2 respectively. But because we do the bind, even though it's bidirectional, because we have D1 initially as the object on the calling object, and D2 is the past object acting as a parameter, because we did it that way, then the first effect is for D1 to be bound to D2 and change its value. But after that, there's no difference between D1 and D2. If we had bound the other way, if we had said D2.bind bidirectional D1, then what would happen is the first line of the output would look different, and what we would see there would be D1 is 1.0 and D2 is 1.0. But after that, after we've done the bidirectional bind and then we make changes to either D1 or D2, any change we make is reflected in both of them equal, and they become indistinguishable one from the other. So you can no longer tell whether you did a D1.bind bidirectional D2 or whether you did a D2.bind bidirectional D1. You can only tell at the beginning, and then after that, once you get moving and you start to change either value, they become indistinguishable one from another.